Picture this. In 1976, 10,000 Americans wrote monthly checks to the L5 Society. They weren't donating to charity. They were buying their future, a retirement home floating between Earth and the Moon. These weren't conspiracy theorists. These were Boeing engineers, NASA mathematicians, MIT graduates who'd calculated Apollo's orbital mechanics. They carried membership cards promising a home at 5 pounds, the fifth Lagrange point, where a city could float forever without fuel. Here's the part that should keep you awake. The physics was bulletproof. The engineering? NASA signed off on every rivet. Congress held 18 months of hearings with Nobel laureates. Princeton physicist Gerard O'Neill didn't just dream these cities. He derived them from Newton's equations, as inevitable as gravity itself. So here's the question. We had the blueprints, the technology, 10,000 people ready to leave Earth. Why are you watching this from a planet's surface, breathing recycled air, when you could have been born in a cylinder of infinite horizons? September 1969. Neil Armstrong's moon footprints are weeks old. In a Princeton classroom, Professor Gerard O'Neill asked his students a question that seemed insane months earlier. Is the surface of a planet really the right place for an expanding technological civilization? The students laughed. Then O'Neill showed them the math. A cylinder 32 kilometers long. Manhattan rolled into a tube. Spin it once every 2 minutes. Fast enough to feel normal Earth weight. High school physics. F equals m omega squared r. Civilization-changing implications. For 5 years, O'Neill transformed napkin calculations into engineering specifications. With his wife, Tasha, a sculptor, and colleagues like Freeman Dyson, they designed not just habitats, but homes. The breakthrough. May 1974. A Princeton conference room. O'Neill presented to NASA officials, aerospace contractors, and one science journalist who wrote the room smelled like history being made. Within 6 months, NASA allocated 500,000 to 500,000 to 500,000. 3 million today. For the 1975 summer study at Stanford. 28 of America's brightest minds locked in Stanford for 10 weeks. Engineers from Grumman, who built the lunar lander, worked alongside sociologists, agricultural specialists, psychologists. They produced NASA document SP413, a blueprint so detailed it specified the thread count of bed sheets in space apartments. The cat moment. July 23, 1975. Rayburn House Office Building. O'Neill faces the House Subcommittee. Senator William Proxmire, future creator of the Golden Fleece Award for Government Waste, jabs his pen. Professor O'Neill, you're asking us to believe we can build cities in space when we can't even fix the potholes in Washington, D.C. O'Neill's response changed history. Senator, the pothole exists because we're fighting gravity every day. In space, we control gravity. We make it, we shape it, we live inside it like a song. The room went silent. Space colonies transformed from academic exercise to American policy debate. October 6, 1973. 2 p.m. EST. Americans are watching football when the broadcast cuts. Egypt and Syria launch a surprise attack on Israel. Within 2 weeks, OPEC announces an oil embargo. Gas prices quadruple in 6 weeks. Fistfights break out at gas stations. Auto workers are laid off by the thousands. The American century, choked by foreign oil, appears to be ending. Imagine reading O'Neill's proposal in the morning paper. Solar power stations the size of Manhattan, floating in eternal sunlight, beaming unlimited clean energy to Earth. Never again would America bow to petroleum dictators. L5. Society membership applications, 50 per week, flood in at 50 per day. But the 1970s apocalypse ran deeper. In 1972, the Club of Rome published The Limits to Growth, a computer simulation showing civilization collapsing by 2000 from overpopulation, resource depletion, ecological catastrophe. It sold 30 million copies. Humanity had 40 years left. O'Neill offered deliverance through mathematics. Earth could support maybe 10 billion. The asteroid belt contained enough material to build O'Neill cylinders housing 20 trillion, 5,000 times Earth's population, living in custom-designed worlds with perfect weather, no pollution, and cosmic views. Meanwhile, 400,000 aerospace workers faced their own apocalypse. After Apollo 11, NASA's budget was butchered, falling 50% in 3 years. Engineers who touched the moon were selling insurance, teaching high school, driving trucks. L5. Society meetings became refugee camps for space-age orphans. The Cat Moment. May 25, 1977. Star Wars opens. Within 6 months, it's the highest-grossing film in history. Suddenly, space isn't about survival. It's about destiny. L5. Society membership explodes from 1,000 to 10,000 in 8 months. Chapters form wherever NASA has a center. But in NASA headquarters, a classified report circulates. Economists ran the numbers on O'Neill's colonies. The conclusion, never released. Economically unfeasible for the remainder of the 20th century and likely beyond. The dream and reality race toward collision. Close your eyes and imagine standing in an O'Neill cylinder. Beneath your feet, ordinary Kentucky bluegrass. NASA tested 47 varieties. It handled artificial light best. Look straight up. Instead of sky, you see land. Rivers running upside down. Houses with people tending gardens. Their feet pointed at your head. Separated by 6.5 kilometers of air that gets hazier with distance until it looks exactly like Earth's blue atmosphere. The design wasn't arbitrary. Every measurement came from human psychology. The cylinder is 32 kilometers long, the maximum distance the human eye needs to feel landscape. It rotates at 0.5 RPM because faster would cause constant nausea from Coriolis effects. 3 valleys, 3.5 kilometers wide, alternate with 3 window strips. The windows aren't just for views, they're for sanity. Studies from nuclear submarines and Antarctic bases proved humans need at least 4 hours of natural light daily to avoid depression and psychosis. Mirrors outside would direct sunlight through windows, creating a 24-hour day-night cycle. Sunset would be slow, mirrors folding closed, stars emerging like a planetarium of reality. NASA hired artists Don Davis and Rick Guidis not for propaganda but for engineering visualization. Davis's interior view, showing rivers bending into sky, had every tree's location calculated for optimal CO2 absorption. Guidis's exterior, showing electromagnetic mass drivers launching lunar soil, illustrated actual engineering. The Cat Moment. June 1976. A junior analyst at Marshall Space Flight Center calculates space shuttle launch requirements for Island 1, the smallest starter colony for 10,000 people. The number, 10,000 flights minimum. NASA promised the shuttle would fly 60 times per year. At that rate, Island 1 would take 166 years to build. Recalculating with improvements. 50 years to build something housing fewer people than a small town. But nobody told the artist to stop painting paradise. February 13, 1977, 4:47 p.m. NASA Administrator James Fletcher opens a manila folder. Confidential Economic Analysis. O'Neill Colonies. His coffee goes cold. The numbers are brutal, O'Neill claimed. 100 billion for 1 million people. 100 billion for 1 million people. 100 billion for 1 million people. 500 billion today. NASA's economists, using actual shuttle development costs, calculated $3 trillion minimum. With realistic contingencies, $10 trillion. For perspective, $10 trillion was more than the entire planet's GDP in 1977. The space shuttle, the miracle machine, was hemorrhaging money. Promised at $10 million per launch, it cost $500 million. Each of the 10,000 flights for a small colony would cost more than Apollo 11. But economics were just the first gravestone. Technical realities were crueler. Cosmic radiation required 6 feet of shielding. Millions of additional tons. Millions of additional launches. The $10 trillion estimate was optimistic. Then came the biological betrayals. Closed-loop life support. Recycling every breath, every drop of water worked in theory. In practice, NASA tests showed systems degrading, developing exotic molds, accumulating trace toxins. A city in space would slowly poison itself. The death blow, July 1979. The Congressional Office of Technology Assessment publishes Space Colonies and Energy Supply to Earth. Conclusion: even if launch costs dropped 95%, space solar power would cost 300 times more than nuclear power. The report's most damning line: no reasonable projection of technology advancement in the next century would make space colonization economically viable. O'Neill's response in his journal: they counted the cost of everything and the value of nothing. Here's how dreams die, not in explosions but in budget meetings. 1979, NBC News polls Americans. 57% believe in lunar colonies by 2000. 31% expect space vacations. The L5 Society prints bumper stickers. Our children will live in space. 1989, same poll. 23% believe in lunar colonies, someday. 8% expect space tourism, for the rich. L5 Society, hemorrhaging members, merges with the realistic National Space Society, striking all mention of colonization target dates. 1999. Nobody bothers polling. Gerard O'Neill watched this collapse from a Princeton hospital bed, dying of leukemia. In his final interview, 3 weeks before his death in April 1992, he's asked what went wrong. "We forgot," he whispers, "that the greatest distance between Earth and space isn't measured in kilometers. It's measured in imagination." The irony compounds. Today's space billionaires explicitly reject his vision. Elon Musk calls rotating habitats romantic but impractical, choosing Martian caves. Jeff Bezos, whose Blue Origin company is named after O'Neill's vision of Earth as a pristine garden, focuses on lunar bases where humans live like moles, not angels. NASA's crown jewel, the International Space Station, $150 billion for 6 people in a tin can, stands as a monument to diminished ambitions. It's not even self-sufficient. O'Neill's smallest design housed 10,000 in Garden Paradise. We built housing for 6 in an aluminum tube. The transformation completes in Silicon Valley conference rooms. 2019. Gateway Foundation announces a rotating space hotel. Their press release mentions O'Neill once as early inspiration. Their design houses 400 tourists, not 20 million residents. A gift shop but no schools. Restaurants but no factories. Views of Earth but no future for humanity. The L5 Society members from 1976, who paid their dues believing they'd retire among the stars, are retiring now, on Earth, in Florida. Their membership cards in drawers, relics of journeys never taken. The O'Neill cylinders exist today as paintings. NASA document SP413 remains freely downloadable, its calculations as valid as Newton's laws. Every equation balances. Every blueprint connects. Every dream remains technically possible. We solved every technical challenge O'Neill identified. SpaceX dropped launch costs 90%. 3D printing could build structures in vacuum. Closed-loop life support keeps astronauts alive for years. AI could manage complexity. Nuclear propulsion could move mass. We have everything O'Neill needed, except the one thing he assumed we'd never lose: the belief that we deserve the stars. The cruelest equation. Those 10,000 L5 Society members, convinced they'd retire at Lagrange point 5, are retiring at Lagrange point 0. Earth. The gravity well we never escaped. Their monthly dues bought them memory, not destiny. Their children, promised lives among the stars, argue on Twitter about Mars versus the Moon while living on neither. Here's what haunts. The O'Neill cylinders aren't waiting for better technology, cheaper launches, or political will. They're waiting for a species that remembers it once believed it was meant for infinity. The blueprints gather dust not in NASA archives, but in our imaginations. That space between dream and dare where humanity's real fate is decided. The savage truth. We didn't fail to build cities in space. We succeeded in convincing ourselves we're not the kind of species that builds cities in space. That's not engineering failure. That's evolutionary surrender. So here's my question honestly. If SpaceX achieves $10 per kilogram launch cost tomorrow, making O'Neill's economics suddenly work, would you leave Earth? Not visit, not tour, but leave Earth forever for a cylinder of infinite horizons? Or have we already chosen our cage, decorating our prison with better smartphones, while the stars wait for a species brave enough to claim them? Tell me, what would it take? What miracle? What disaster? What revelation? To make you surrender your Earth address for coordinates at L5. If you enjoyed this story, hit subscribe for more stories where history, technology, and human ambition collide. Thanks for watching.